Next, we're going to take a look at solving multi-step equations. So these take a little bit more effort, but the process is exactly the same as what we saw with the two-step equations. And our essential question will be the same almost for this whole unit. How can I apply the golden rule of algebra to solving equations? Our first example, we have like terms. So I'm going to start by simplifying my like terms and combining them. Make sure that you pay attention to what symbol is in front of each term. So I have 6p minus 3p, which gives me a total of 3p. My minus 2 comes down, equals 16. Now it's a solve by undoing, so we're going to cancel the minus 2 by adding it. The reason we're going to cancel the minus 2 first is because it comes last in order of operations. And when you solve equations, you use order of operations backwards. So we get 3p equals 18. To cancel that multiplying by 3, I'm going to divide both sides by 3, and I'm left with p equals 6. Our next problem, we have distributive property. There's two ways to solve this one. We can distribute the 8 and then solve by undoing like we did on the last one, or we can understand that everything in parentheses is tied to that 8 by multiplication, so I can start by dividing both sides by 8. This actually saves us a step when we're solving, because instead of multiplying and then dividing, we just divide to cancel the multiplication. So 64 divided by 8 is 8, and on the side with the variable, remember you should always be canceling. You should never be doing any math or any operations on the side with the variable. The reason that we're doing what we're doing is to get the variable alone and to get something to cancel. So the next thing I'm going to cancel is that plus 2, and subtraction cancels addition, so I'm left with 6 equals k. We have like terms again on this one. This time our like terms are the numbers instead of the variables. Negative 28 plus 11 is negative 17 minus our 22w equals 31. So next I'm going to cancel that minus 17 by adding it, again using order of operations backwards. Don't lose that negative sign in front of the 22. A lot of students, once they cancel something in front of a subtraction sign, they drop it instead of turning it into a negative sign. If it's an addition sign, we can drop it because that would leave it positive, but a subtraction sign means it's really negative. Now we're going to divide both sides by the negative 22. Again, another error, it's usually with the negative signs. Students will drop the negative sign when they divide. Remember, a negative divided by a negative gives us a positive, and we want to solve for positive w, not negative w, so don't lose track of those negative signs. On the right-hand side, 22 doesn't quite go into 48 evenly, so we're going to simplify. They're both divisible by 2, and when we simplify fractions, we bring the negative to the numerator. So it doesn't matter if you have the negative on the numerator or the denominator, but typically we put it up in the numerator. 48 divided by 2 is 24, and 22 divided by 2 is 11, so we have negative 24 elevenths. Now we're going to take a look at a couple of fraction ones. I know these are tough, so we're going to spend some extra time on these in order to get really good and comfortable with fractions. So remember, in order to cancel the fractions, we multiply everything, following that golden rule, multiply everything by the common denominator. In this case, 3 and 4 both go into 12, so I'm going to distribute this 12 to each term. Remember, when you multiply a fraction, you can divide first, because multiplying and dividing are in the same step. If you multiply and then divide, you'll get the same answer as if you divide and then multiply. So 12 divided by 3 is 4, and then I still have the times 2 in the numerator. My second term, I've got 12 divided by 4 is 3, and I still have the times 1n. And on the right-hand side, 3 times 12 is 36. There was no fraction to cancel the 12 on that side. So now I'm going to simplify the left-hand side by multiplying. And then we can solve by undoing. The 8 is the last step in order of operations because we have the n times negative 3. Another common mistake is students see that subtraction sign and think they need to add to cancel. The subtraction sign is for the 3. It is not for the 8. My 8 is positive, and in order to cancel a positive 8, I need to subtract. Again, don't lose that subtraction sign. It turns into a negative sign. And 36 minus 8 is 28. Dividing both sides by -3, again, not losing track of that negative sign. Our -3's cancel, leaving us with n equals -28/3 because 3 does not go into 28 evenly. Our last question, again, finding that common denominator for 6, 4, and 2. A trick, if you're having a hard time coming up with the common denominator, is to take the biggest number and start multiplying until you come up with something that works for everything. Since 4 does not go into 6, we're going to take 6 times 2, which is 12. 6, of course, goes into 12. 4 goes into 12, and so does 2. So we're going to multiply all of our terms by 12. Again, in order to make this simpler, I'm going to divide first and then multiply. 12 divided by 6 is 2 times 5x. That was left from the fraction. 12 divided by 4 is 3 times the 3 in the numerator equals 12 divided by 2 is 6. And of course, the 6 times that 1 in the numerator wouldn't change anything. So now on the left-hand side, I'm going to multiply. 2 times 5x is 10x, plus 3 times 3 is 9, equals 6. And then solving by undoing, I'm going to subtract 9 from both sides to cancel that addition, which comes last in order of operations. 6 minus 9 is -3. Again, be careful for that negative sign. And dividing both sides by 10, I get x equals -3/10 because 10 does not go into 3 evenly, and they don't have a common factor, so we can't simplify. Here are 2 questions that I would like you to attempt before coming to class so we can start off with our warm-up.